Good evening, madam. My name is C. Kishore Kumar. I am from second year civil department in SRD. Today's topic is specific energy and critical depth in open channel flow. Introduction to open channel flow. Open channel flow refers to the movement of water with a free surface such as river canal. It characterized by the flow depth and velocity which are influenced by the channel geometric and flow condition. Understanding flow behavior in open channel is essential for hydraulic engineering and water resource management. Definition of specific energy. Specific energy is a total energy relative to the channel bottom per unit weight of water at a section. It includes both the potential energy depth and the kinetic energy of flowing water. Specific energy is useful concept for analyzing rhythms and flow transmission in water channel. Formula for specific energy. Specific energy E is given by the equation E is equal to y plus v square by 2g, where y is flow depth and v is the velocity. It is typically measured in a meter or feet depending on the system of units used. Equation relates the flow depth and velocity, helping to analyze flow behavior at different conditions. Concept of critical depth. Critical depth is the flow depth at which the specific energy is minimized for a given flow rate. It represents the transmission point between different flow regimes such as transient and rapid flow. Determining the critical depth is essential for analyzing flow stability and designing hydraulic structure. Critical velocity and critical depth. Critical velocity is a flow velocity at which the flow is critical condition and is calculated based on the flow parameter. Critical depth YC can be found using specific formula depending on the channel section, such as for a rectangular channel. At a critical condition, the Froude's number is equal to 1 indicates a balance between inertia and gravitational force. Relation between specific energy and critical depth. The specific energy curve shows a minimum point at the critical depth for a given flow rate. For depth less than critical depth, the flow is supercritical. For greater depth, it is subcritical. Understanding this relationship helps in predicting flow behavior and designing condition structure. Geographic representation of specific energy. Gra- Graphs of specific energy reference flow depth insulates the minimum energy at a critical depth. These graphs are used to analyze the flow, transition, stability, and to determine the flow rhythms. Critical point on the graph indicates the flow condition where the specific energy is at its lowest for a given discharge. Application in hydraulic engineering. Knowledge of specific energy and critical depth is vital in designing spillways, waves, and gates. This helps in controlling flow, preventing erosion, and managing risk, flood risk. This concept are also used in flow measurement and hydraulic modeling. Summary of key points. Specific energy combines potential and kinetic energy to analyze open channel flow condition. Critical depth makes the transition between subcritical and supercritical flow regimes. Understanding this concept is crucial for effective hydraulic design and flow management. Con- Conclusion and future reading. Masters of specific energy and critical depth enhance the ability to analyze and design open channel system. For advanced studies, explore fluid mechanics textbook and hydraulic engineering resource. Continuous learning in this area supports sustainable water management and infrastructure development.